Hello students, today in math practice we are going to study application of integrals. We already know integration means basically finding the area under the curve. Let us study some examples to see how integration can be applied. So basically in integration we generally find the area under the curve. Suppose you are having a curve fx, we can apply integration to find the area which is bounded by the curve fx, x-axis and the ordinates x is equal to a and x is equal to b as shown in the figure. Now this area under the curve, you can think that it is composed of infinitely many large, or you can say very large number of very small vertical strips which are rectangles. So suppose if you consider one such arbitrary strip which has height say y and width which is dx, very small width, then dA, that is the area of the elementary strip, will be given by y into dx. Area of rectangle, length into breadth, so it is y into dx. So when we add up all such elementary areas of thin strips, we get the total area under the curve. So the total area of the entire region, suppose we denote by A, so it is integral from A to B y dx or integral from A to B fx dx. Now suppose instead of this, instead of having the curve above your x-axis, if your curve is as shown in the second figure, then the area of the region bounded by the curve x is equal to gy, y-axis and y is equal to c and y is equal to d can be given as area is equal to integral c to dx dy or gy dy. Also remember one thing, that if the curve is on the negative side of any of the axes, then when we find the integral we get a negative value. Area is never negative, so we consider the modulus value for it. So consider the first example. Let us find the area enclosed by the circle x square plus y square is equal to a square, means the radius of the circle is a. Now you know that if we find the area of one of the quadrants and you multiply by 4, you get the total area of the circle. So the area of the circle A will be equal to 4 into integral of, now the area is bounded by x is equal to 0, x is equal to a and the curve, correct? So it will be 4 into integral of 0 to a y dx. From the equation of this circle x square plus y square is equal to a square, y will be equal to root of a square minus x square. We already know the integral of root of a square minus x square. So when we put it in this, you will be getting x by 2 root of a square minus x square plus a square by 2 sin inverse x by a. First put the value of x as a, then put the value of x as 0. So when you put the value of x as 0, it will be 0. When you put the value of x as a, it will be a by 2 into 0 plus a square by 2 sin inverse of 1. But what is sin inverse of 1? Pi by 2, because sin pi by 2 is 1. So when you simplify it, you get it pi a square. So directly, if suppose you are asked an example saying that find the area lying in the first quadrant and bounded by the circle x square plus y square is equal to 4. You have to find the area of the circle x square plus y square is equal to 4 bounded by the lines x is equal to 0 and x is equal to 2. Then the area directly you put in this formula. Since they are asking only for the first quadrant, you need to divide by 4. So it is 1 upon 4 pi into a square. A radius is over here 2. So 2 square, which is equal to pi after simplification. Second thing is we can find the area enclosed by the ellipse. The equation, general equation of the ellipse, x square upon a square plus y square upon b square is equal to 1. So now if you see the diagram again over here, for the first quadrant you can find the area and multiply by 4. Now consider the first quadrant. For that the area will be, the shaded area which we want will be area of the region AOBA. You can see AOBA, this region which is the first quadrant. It is bounded by the curve, means the equation of the ellipse, x-axis and the ordinates x is equal to 0 and x is equal to a. Correct? And why this is true? Because it is symmetrical about the x and y axis. So area will be 4 into integral 0 to a y dx. Now over here y, if you make subject of the formula, it will be equal to b upon a root of a squared minus x squared dx. Take out 4b upon a. Again integral of root of a square minus x square, we know it is x by 2, root of a square minus x square plus a square by 2 sin inverse x by a. It is similar like we have seen in the previous example for the circle. So that will be a square by 2 into pi by 2. Right? When you simplify this, you will be getting it as pi into a into b. So directly suppose if you want to find the area of the region bounded by the ellipse x square by 16 plus y square by 9 equal to 1, means your a is 4 over here and b is 3. So it will be pi into 4 into 3, which is 12 pi. Now in the third example, sketch the graph of y is equal to x plus 3 and evaluate integral minus 6 to 0 mod of x plus 3 dx. Now first of all, when you try to plot the graph, you take the different values of x from minus 6 to 0 and find the value of y. The graph is as shown over here. Now it is the mod function. We have discussed this previously also. You have to divide it into two parts whenever your function is negative and when it is positive. So from minus 6 to 3, when x is between minus 6 and minus 3, the value of the function will be negative. So how is the mod function defined? It will be defined as minus of x plus 3 between x running from minus 6 to minus 3. And from x running from minus 3 to 0, it will be x plus 3 by the definition of the mod function. So the integral will be minus 6 to 3 minus of x plus 3. In this interval, the function is defined as minus of x plus 3 dx plus integral minus 3 to 0 x plus 3 dx. Then it is simple, x square by 2 is the integral of x and 3 integral is 3x. Upper limit minus lower limit, put the values and just simplify it properly. You will be getting the answer as 9 square units. Find the area bounded by the curve y is equal to sin x between x is equal to 0 and x is equal to 2 pi. Now you can see the graph of sin theta. You know that sin 0 is 0, sin 2 pi is 0, in between sin pi by 2 is 1, sin of 3 pi by 2 is minus 1. So this is how sine function behaves between 0 and 2 pi. Now over here also you can see that since in the first part from 0 to pi sine is positive above the x-axis, but from pi to 2 pi it is negative, means below the next x-axis. So as I told you, even if the area is negative, you have to consider the value as mod, positive value. Area will always be positive. So in the second case I have written mod because you have to consider the mod value, area will be negative. The curve is below the x-axis. Integral of sine is minus cos. Put the values, upper limit minus lower limit. So take care while you put the values 1 and minus 1. Accordingly, in the second case, even if your area is minus 2, you have to consider 2. So it is 2 plus 2, which is equal to 4. Now some different type of examples. Find the area lying between the curves y square is equal to 4x and y is equal to 2x. Now you know y square is equal to 4x, equation of a parabola, and you have y is equal to 2x. Y is equal to 2x, which is the equation of a line. Now first of all, when you try to draw these graphs, you just take some points. Suppose if I take the value of x as 0, then y square is equal to 0, means y is equal to 0. If I take the value of x as 1, y square is 4, means y is equal to 2. So 1, 2 will also be a point on the parabola. Similarly, you try to plot the parabola. For the line y is equal to 2x, same way, take the value of x as 0, 1, minus 1, you will be getting the line. Now, if I want to find the area between these two curves, then I need to find their point of intersection. That means you equate both the y's, both the functions you equate. So, when you equate both the functions, it is basically y square is 4x, and in the second case for the line y square is 4x square. So if I equate 4x is equal to 4x square, taking 4x common, 4x into x minus 1 equal to 0. So either x can be 1 or x can be 0. Only two possibilities are there. And from the graph itself also it is clear that either x is 0 or x is 1. So the required area will be the area which is bounded by the parabola and the x-axis. The whole parabola you consider and the x-axis you consider, minus the area which is bounded by the line and the x-axis. Always see, whenever you are taking over here, when I am saying that x is 0 and x is 1. These two are the points. So I need to find the integral between 0 to 1. But how will I find this shaded region? It will be the total region of the parabola and the x-axis minus the total region of line and the x-axis. This will give you the shaded portion. So the first area is integral 0 to 1 2 root x dx, and mod is written basically because even if you get negative value, you have to take positive value. If you get positive value, no problem. Similarly, second area is integral 0 to 1. In the second case, what is the equation of y or fx which you say? It is 2x. So it is integral 0 to 1 2x dx. Upper limit minus lower limit. When you put the values, you get 1. So the required area will be 4 by 3 minus 1, which is 1 by 3 square units. So always in these type of examples, try to take approximate points and draw the diagram. Next, different type of example. Find the area bounded by the curves x minus 1 whole square plus y square is equal to 1 square and x square plus y square is equal to 1 square. You know that these are equations of the circle. First case, x minus 1 whole square and y square means y minus 0 whole square. So it is the circle with center 1 0 and radius 1. X square plus y square is equal to 1 square. The unit circle, which is the circle with center 0 0 and radius 1. Now you have to find, this is the diagram. You try to first of all draw the diagram by taking the points. Now the point of intersection, we will find this by equating both the y. So what we do over here is we equate both the y square values. That means 1 minus x minus 1 whole square is equal to 1 minus x square. When we do this, basically you are getting x minus 1 whole square is equal to x square. So actually you'll be having two type of cases over here. In the first case, when you consider x minus 1 as minus x, you get x as half. And in the second case, if you consider minus of x minus 1 as x, then you will be getting x as minus half. Also from the diagram, you can see that there are 2 points of intersection. In the first case, it will be x as half, and second case, negative value of x. So that is minus half. And obviously, when you put the value of x as half in the equation, you will be getting y square is equal to 1 minus 1 upon 4. That is 3 upon 4. When you take the square root, y will be equal to root 3 by 2. If it is half, it will be root 3 by 2. If it is minus half, y will be minus root 3 by 2. So these points also are clear in the diagram. Now our required area means the area which is enclosed by these two circles, the intersection part. That is basically, you can see AOBCA. This whole area we want to find out. This is equal to 2 times the area of OAC. That means if I just consider above the x-axis, the area below the x-axis will also be the same. Even if it is negative, you consider area as positive. So you can write 2 into mod of area of OAC. Now OAC area, this again you have to divide it into 2 parts. It is OAD plus DAC. Correct? OAD. Here your x runs from 0 to half. You can see x is equal to 0 and x is equal to half. So here your x runs from 0 to half. Here you are having the first circle. You can see over here. It is the area bounded by x is equal to 0, x is equal to half, and the area and the curve x minus 1 whole square plus y square is equal to 1 square. This curve is there. Correct? So For OAD, it will be integral 0 to half root of 1 minus x minus 1 whole square dx. Plus for DAC, for this area, you can see it is bounded by the line x is equal to half, x is equal to 1, and the curve, which is the circle, x square plus y square is equal to 1, this circle, correct? So now, what is the equation of y from this circle? It is root of 1 minus x square. So the second will be integral of half to 1 root of 1 minus x square dx. Again we use our general integration formula, integral of root of a square minus x square dx, x by 2 root of a square minus x square plus a square by 2 sin inverse x by a. So now it is basic calculation, but take care while doing the calculation. One thing is clear. Now see, sine inverse of minus half, that will be equal to minus pi by 6. Sine inverse of half is, means you know that sine pi by 6 is half. Sine of minus pi by 6 will be minus half in the fourth quadrant. Correct? Similarly, sine inverse of minus 1 means you know that sine of minus pi by 2. See, 3 pi by 2 can also be seen as minus pi by 2. So, sine of minus pi by 2 is minus 1. And similarly, sine of pi by 2 is 1. You know this. So, now just put all these values, simplify this. You will be getting the area as 2 pi by 3 minus root 3 by 2 square units. So in this video we have seen how to apply the integration technique to find the area under the curve or area between the curves. Do like and share the video and subscribe to the channel. You can also refer to the complete playlist on integration.